cut all the things. Or we have one more. We'll see. I'll come to this. First, we'll see this one. Last, in the end, we'll go for analysis. Carry on this one. Some concept we are going to generate here that will help us.
Left side fully to spring, sir.
Yeah.
Sir, even the string which is above B mass, the block B will
All the black is spring only, sir.
This you treat, let it this be a string, my dear. But
okay,
this
sir.
is connected to springs. Here, the color I shown, please understand. Huh?
Yes, sir. Spring force is acting on.
How come this? Yeah, how come this is one spring, this is string? These all three are different. That's why you should play kite. What is the reason why we ask you to play? No, this is very important. If you don't play things, very difficult, not possible to become engineer. Playing things with different objects is very essential in childhood.
We'll experience tension.
Then all the things are there. No? When you don't play anything, directly come and want to become engineer, how it is possible? I don't know what so many stupid schools, colleges are there where they're against playing. How it is possible? Huh?
Yeah, I do play kites.
Okay, now let me draw the pose diagrams. In your notebook, don't draw so many diagrams. You have to have a good explanation. I'm going for the diagrams here.
Sir, your
So your voice is
In the
breaking.
existing one diagram only, there only show it, and after cutting, you go for two diagrams. I think okay, fine. First, we'll start.
Sir, your voice is breaking, sir.
Let me continue. Okay, now at equilibrium, let me go for it. 3 mg. Here, spring will be elongated. Kx. This is kx. Show it here. So this is a kx. Kx minus 3 mg 0. So okay, that kx equal 3 mg. Then at this particular point, you look at this one. Mg will act. It will have some tension. Here tension T. Mg. Let some tension T naught. Let's find out what is the tension. Kx minus mg minus T equals 0. Kx equal to 3 mg. T naught has to be, okay, can we get the tension T naught? That also we can do it. T minus mg minus T naught equals 0. Okay, we got tension, spring force, everything. Okay, now I'm going to cut it. Everyone is B and C is something not analyzing properly. It's not wrong, not analyzing properly. So no question of this. Keep it here. The string is cut. No. No, Pranay. Okay, now I'll explain. You make observation. 3 mg. Spring force. Now I'm going to say Okay, the spring force will not change. Why spring force will not change? Why the spring force will not change? Okay, when I cut this string, sudden change in spring force here not possible. You can see, but sir, like this is connected, this block C. See, first what will happen? The block C should accelerate. Due to acceleration from rest, it should get into inertia of motion. Then after some time, B and C will undergo displacement. Then this end of the spring will have displacement. But we are discussing just after. So therefore, there is no change in spring force. So the Kx will remain as it is. Here also I'll bring Kx. This is what happens. So definitely, what is the block A? 3m into acceleration of block A equal to Kx equal to 3mg. So block A, we are discussing problem just after only. Let's see here, the weight will act, the weight will continue to act. What will happen to the tension? This is very important. The tension is going to change some other value, T dash, some other value. Sir, sudden change in tension possible, S. Sudden change in spring force, not possible. So there's one golden statement is what I should add up somewhere here. Possible. Sudden very important. All these numericals just revolve around these ideas. Sudden spring force is possible when you cut spring. That's all. When you cut spring, yes, okay. Let's put some sort of statement. Huh? Now come for this one. So sudden change, yes, there will be some change in tension. So why you are changing? Why don't you keep T only? No, earlier you see that one mg plus T naught were there. Now this T naught suddenly vanished. This tension has to change. So T dash will put it. Now Kx, look at the spring force, how much Kx is there. This force should be, so let it accelerate up. Why you are putting same acceleration? Next, one more beautiful question here. They're connected by a common string. The accelerations must be equal. Block B and C, they're connected by a common string. The accelerations must be equal. So therefore now, so what we do is like Kx minus mg minus T dash equal to ma. T dash minus mg equal to ma. Masses are same. Let me add up these two. And let me add up these two. So it will be Kx minus 2mg equal to 2ma. Kx equal to 3mg. Now what is the acceleration of the blocks? Many of you gave answers. Intentionally I was asking you to check it, means I wanted you to really think. If I say wrong, no, you'll start analyzing still more beautifully. Intentionally some of you gave very good answers. G by 2. What is this? Acceleration of both the blocks. And it will be upward. What is the tension? Can we calculate tension? Yes. T dash minus mg equal to ma. Okay, look at now. Earlier what was the tension? 2 mg. Now it will become 3 mg by 2. Slightly it will decrease. because this pull force is decreased, no? Earlier T was balancing mg and T naught, so definitely when you take out this T naught, tension has to change. So therefore I'm ending up with a decreasing value. B and C will have common aggression because they're connected by a common string. I think this is very, very essential. Some of you gave this answer. Four students gave this answer, but intentionally I said wrong so that you can go and think still more where we are going wrong everything. Now here afterwards, in this such numericals, if the blocks, if they are connected by a string, if any one block moves, the other block should also move, and they must have common acceleration. And this tension you cannot assume, it should be derived. Just let it be T dash and it has to be determined. You cannot directly take this value 2 mg, 5 mg, mg by 2. No, we don't know this. That has to be derived. Some spring cut we'll see. One problem will do at least spring when spring is cut. Oh, all the questions are thread burnt only.